The next problem is the following alternatives can perform the same function. So here in the problem they have given alternatives, alternative A, B, C. First cost 6,000, 3,000, 2,000. Life 6 years for alternative A, 3 years for alternative B and 3 years for alternative C. The salvage value they have given 2,000 for alternative A, 1,000 for alternative B and nil, no salvage value for alternative C. And annual cost they have given 800, 1,000, 1,200 for A, B, C respectively. So here at an annual rate of 12%, rate of interest they have given, that is 12%, rank the alternative as per equivalent annual cost. Equivalent annual cost. This is what the problem. So now we are solving the problem based on annual equivalent worth. The word annual equivalent worth or equivalent annual worth all means the same. So how to solve such type of problems? In the previous lectures we have seen present worth, future worth as well, right? So in present worth and future worth, if you have different lives, okay, so you will going to proceed with LCM method. In annual equivalent worth, the main advantage here is, here you can observe the lives for 3 different alternatives, it is different. For alternative A is 6, for alternative B is 3 and for alternative C is 3. The advantage of annual equivalent worth is, if you have different lives, you no need to proceed with LCM method. In the previous cases, such as your present worth and future worth, you had proceeded with LCM method. In annual equivalent worth, you no need to proceed with LCM method. So you can directly take the life for alternative A as 6 itself, for B as 3 and for C as 3. Okay, for the same problem, if they had asked like to find, compare the various alternatives based on present worth, at that time you need to proceed with LCM method. So LCM of 6 and 3 is 6. So this alternative B, you have to make 2 CFDs, right? So here you can directly take 3 in annual equivalent worth. If you go for LCM method considering annual equivalent worth, you will get the same answer. So no need to proceed with LCM method in such cases. Fine, we shall try to solve this. So here annual equivalent worth, all quantities we are going to convert to A. So saying that, like if you have salvage value, that is future value, that you are going to convert to A, and here you have annual cost, that is already annual, that is annually converted to A. No need to convert this part. This first cost, that is P, you need to convert to A. Okay, so we shall solve alternative A. So to find annual equivalent worth of alternative A. Okay, what are all the given datas? So they have given first cost. First cost is nothing but P. P, how much they have given? Rupees 6,000 they have given. Okay, so life they have given, that is N they have given as 6 years. Okay, salvage value they have given, that is nothing but your future. Salvage value they have given as rupees 2,000. Annual cost they have given, that is annual cost they have given, that is A. How much they have given? Rupees 800. And rate of interest they have given as 12% compounded annually. So these are all the given datas. So now you have to proceed with cash flow diagram. We shall draw a cash flow diagram. Total how many years they have given? They have given 6 years, right? 0, 1, 2, 3, 4, 5 and 6. Okay, so first cost they have given, that is 6,000. At time 0 the cash flow is downward arrow. P they have given, how much they have given? 6,000. Okay, next salvage value they have given, that is future value. How much they have given? Here rupees, that is F, they have given rupees 2,000. Okay, annual cost they have given. They have given annual cost, not annual revenue. So it is downward arrows, right? So how much? These are all A. A they have given as 800. Okay, rate of interest they have given as 12%. This is what the cash flow diagram for the given alternative. Okay, so how we shall calculate this? Annual equivalent worth of alternative A is given by annual equivalent worth inflow minus annual equivalent worth of outflow. Correct? Revenues minus cost. So in this problem, revenue we have only the salvage value, that is 2,000, right? So this we need to convert to A. Correct? How to convert? We know what is F. To find A, when F is known, I comma N. This is only the revenue, right? So minus cost, we have P, we need to convert to A. So how to convert this? We know what is P. To find A, when P is known, I comma N. Okay, plus. So this is already converted to A, no need to convert further, so you keep as it is. Okay, so F is how much? 2,000. 2,000 into, to find A when F is known, I is 12%, N is 6 years, minus P is how much? 6,000. To find A when P is known, I 12%, N 6, plus A is 800. Okay, so if you just solve this, you have 2,000. A bar F, you have 0.1232 minus 6,000. A bar P, you have 0.2432 minus 800. If you just calculate, you will get annual equivalent worth of alternative A. You will get it as minus 2012. So you will get annual equivalent worth as, for alternative 1 is minus 2012. This is how you need to solve for A. In similar lines, we shall solve for B and C. Next, for alternative B, to find annual equivalent worth for alternative B. So what are all the given data? So here they have given first cost, they have given, that is P, rupees 3,000. Life they have given, N 3 years. Salvage value they have given, how much? 1000 and annual cost they have given 1000. Okay, so we need to draw cash flow diagram. So for 3 years, right? So it is 0, 1, 2 and 3. Okay, first cost they have given as 3000, that is P, 3000. Salvage value, that is future value, they have given as 1000 and annual cost they have given as 1000. Okay, rate of interest they have given as 12%. This is future value or salvage value. So here what you need to do, you need to convert this P to A. A is already converted and future amount to A, correct? So to find alternative annual equivalent worth of alternative B, annual equivalent worth of alternative B is nothing but annual equivalent worth of revenue minus annual equivalent worth of all cost. So in the problem you have only one revenue, that is future amount, you need to convert to A. So you know what is F. To find A when F is known, I comma N, minus P you need to convert to A. So here you know what is P. To find A when P is known, I comma N, plus A is already converted. Okay, if you just find out F they have given as 1000, A bar F, I how much, 12%, N is 3, minus P 3000, A bar P I 12%, N 3, minus A they have given as 1000. From compound interest table, if you just find out the values, you will get A bar F as 0.2963 minus 3000. For A bar P you will get it as 0.4163 minus 1000. So if you just find out annual equivalent worth for alternative B, if you just substitute, you will get minus 1952. This is the value you got it, annual equivalent worth for alternative B, you got it as minus 1952. Here we have taken directly, we have taken N as 3, right? If you proceed with LCM method also in annual equivalent worth to compute annual equivalent worth, you will get the same answer. If you just combine two CFDs in order to make one big CFD, why? Because LCM of 6 and 3 is 6, you will get one more attachment, right? 3 plus 3. So if you just calculate, you will get the same answer. That is the biggest advantage of annual equivalent worth. So in the similar lines, we need to solve for alternative C. Next we shall find out for alternative C. To find annual equivalent worth for alternative C. Here for alternative C, they have given first cost, they have given as rupees 2000, life they have given as 3 years, salvage value is nil, okay, annual cost they have given as rupees 1200. Next we shall Draw CFD 0, 1, 2 and 3. First cost they have given as 2000, that is P 2000. Annual cost they have given as 1200. 1200. Salvage you don't have any, that is 0. So rate of interest it is 12%. In the similar lines, annual equivalent worth for alternative C. Annual equivalent worth revenue minus annual equivalent worth cost. Okay, revenue we don't have anything, so it is 0 minus P, we know P. To find A when P is known, I comma N plus A. Okay, so what is P? How much they have given? They have given as 2000. A bar P, I 12%, N 3 minus A they have given as 1200. If you just find out, minus 2000 into 0.4163 minus 1200. So you will get it as annual equivalent worth for alternative C. You will get it as minus 2032. So this is what the answer we got it for alternative C. So how much we got it for alternative AEW? For alternative A we got it as minus 2012. Okay, so annual equivalent worth for alternative B we got it as minus 1952. Okay, annual equivalent worth for alternative C we got it as minus 2032. Okay, this is what the alternatives we got it, right? For alternative A we got it as minus 2012, for alternative B we got it as minus 1952, and for alternative C we got it as minus 2032. By comparing these three alternatives, so since the values which we got it as the cost, okay, the negative values, so it means to say which is having the least value, that we need to select it. So comparing these three, alternative B is having the least value, so this alternative B can be chosen. This is what you need to conclude. So by comparing the various alternatives, alternative B is the best alternative compared to alternative A and alternative C. Why? Because if you choose alternative A, you will be under loss. If you choose alternative C also, you will be under loss. Here also you will be under loss. Why? Because it is a negative sign. But compared to alternative A and alternative C, this is better. That is minus 1952. If you find out in the present worth or in future worth, you will get this alternative B as the best alternative. If you proceed with LCM method also, if you attach one more CFD and if you find out by using LCM method, and if you find equivalent annual worth, you will get the same answers. That is one of the biggest advantage of annual equivalent worth. A production utility can be purchased for rupees 10,000 which is supposed to serve a 5-year term. The annual operating expenses is estimated to be rupees 2500. It is intended to reduce the annual operating expenses to rupees 1000 for the next 5 years by investing in additional attachment worth rupees 13,000 in the 6th year. A similar utility can be leased for 8-year term for a one-time payment with no return of rupees 50,000, assuming an interest rate of 10%. Comment on these proposals. In the given problem, there are two proposals. One is purchase proposal, one more is lease proposal. So here in this problem, they have not specified which one, like present worth or annual worth or future worth. You guys have to remember one thing. For a purchase proposal, the tenure they have given as 10 years. For a lease proposal, they have given as 8 years. You can proceed in any one, right? Either you can go for annual worth or future worth or present worth. But since they have not specified anything, it is always better to proceed with annual equivalent worth. For a purchase proposal, the initial investment they have given as rupees 10,000. So with initial investment of 10,000, for the first year, the annual operating expenses, it is to be 2,500. With an additional attachment of rupees 13,000 in the 6th year, the annual operating expenses, it gets reduced to 1,000. Okay, that is what they have given for a purchase proposal. Okay, solution for this. So we have two proposals. First one is to find annual equivalent worth of purchase proposal for a purchase proposal. So what are all the given data? So here they have given first cost they have given as, that is P, they have given rupees 10,000. Okay, annual cost for first 5 years they have given as how much? Rupees 2,500. Additional attachment of rupees 13,000 in the 6th year, that reduces annual cost to rupees 1,000. Okay, this is what the data they have given. Okay, so we shall draw the cash flow diagram. Cash flow diagram for purchase proposal. How to draw this? First cost they have given, right? I'll write it here. So total how many number of years? So it is 10 years. What is the rate of interest? 10% they have given. Okay. So it is 10 years, right? Zero, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Okay. So first cost they have given as how much? Rupees 10,000. Okay, that is P they have given. Next, annual cost for the first year. How much it is for the first 5 years? It is rupees 2,500. Okay. So with an additional attachment of rupees 13,000, the annual operating cost, it gets reduced to 1,000 for the next 5 years. So here additional attachment is there, that is P, how much? 13,000. So after this additional attachment, so these values, the annual cost, it reduces to rupees 1,000. So rate of interest in the problem they have given as 10%. Okay, we don't have any salvage value. So this is what the cash flow diagram, correct? So I hope the problem is clear. So the problem, it says the initial investment of 10,000. So the annual cost they have given in the problem, that is 2,500. After an additional attachment in the 6th year, the annual operating cost that reduces to 1,000 for the next 5 years. Okay. So here you need to remember, so this P, that is additional attachment, I am investing here, it means to say this is the beginning of 6th year. This is what the beginning of 6th year. So how to solve this problem? How to solve this problem? Here we are proceeding with annual equivalent worth, correct? So you just think here, for the first 5 years the annual operating cost is rupees 2,500. For the next 5 years it is 1,000. It is not equal for the entire life, right? For the entire 10 years the annual cost is not equal. So for such type of problems, how can we solve this? First, what we shall do, we shall convert all the values to P, that is at time 0, then from P we shall convert to A. Okay, so how to convert all the entities to P? Okay, so I'll write to find present worth of purchase proposal. Why we are finding this present worth? Why? Because here you have 2,500 and 1,000. We shall convert all the entities to at time 0, then we shall convert to A. Okay. So here present worth of purchase proposal is equal to present worth of revenue minus present worth of cost. Okay. So here revenue we don't have anything, that is 0, minus this is at time 0. So I can directly take it as 10,000. Okay. Here we have only 2,500 for the first 5 years. How can we write this? Okay, here I will take it as revenue, we don't have anything, that is 0 minus, this is at time 0, you keep as it is. This part, here you have how much, plus, I know what is A, to find P when A is known, I comma N. Okay, so I'll convert this to here, right? So this P you have to consider as future amount, then you need to convert to P. Okay, plus here you have, what I'll do, I'll convert this A to this part and again the sum to P. Okay, what I am doing here, I know what is A, to find P when A is known, I comma N. So what I am doing, I am converting this to this part, right? Plus, so it is already at time 0, I mean at the 6th year. So this part I am going to convert again to P. This becomes your future amount. So how can we write? So to find P when F is known, I comma N. I hope this is clear. This part, so what I have done, I have converted this A at this point, so that is A into, to find P when A is known, I comma N. So plus this P. So this entire thing, it becomes F, that is future amount. So this future amount I am converting to P, that is P bar F I comma N. Okay. So here you have minus, P is how much? 10,000 plus A is 2,500, P bar A, I 10%, okay, N you have to consider only 5, okay, plus this entire thing. A is how much now? 1,000, to find P when A is known, I is 10%, N is 5, plus this one 13,000, right? So this entire thing you need to convert to P, that is P bar F I 10%, N is how much? From here it is 5. Okay. So what will be the answer? Minus 10,000 plus 2,500, P bar A, that is 3.7908 plus how much? 1,000 P bar A, I mean I mean 3.7908 plus 13,000, so into P bar F, that is 0.6209. So if you just calculate, you will get present worth for purchase proposal. You will get it as minus 29851. This value we got it. What we have done, we have converted all the entities at time 0. So what we have to calculate? We have to calculate annual equivalent worth. Now all the quantities are at time 0. Considering this, you need to convert to A. So how to convert this? To find annual equivalent worth of purchase proposal. Okay, so here this implies annual equivalent worth of purchase proposal. I will get it as, so to find I know what is P, right? So I know what is P. To find A when P is known, I comma N. So what is P? P we have calculated. P we have calculated, that is minus 29851. So to find A when P is known, I 10%, N you have to take it as the entire life, that is 10. So minus 29851 into, so you will get it as 0.1627. The final answer you will get it as annual equivalent worth of purchase proposal, you will get it as minus 4856. This is what the answer we got it as for annual equivalent worth for purchase proposal. So we have next thing, that is lease proposal. So in lease proposal they have given the initial investment of rupees 50,000 and with no operating cost or operating cost, so the rate of interest they have given 10% and the number of years they have given as 8. If you solve in a similar way, so you will get annual equivalent worth for lease proposal, you will get it as rupees minus 9370. So here what we are doing, we are converting P to A. So P is known, so we are converting to A. If you compare both alternatives, that is purchase proposal and lease proposal, it clearly indicates that purchase proposal is better. Why? Because you have minus 4856, that is better compared to your lease proposal. That completes the problem.